Students, yesterday already we discussed about position of a point, power of a point. Here already we discussed about this concept yesterday. Observe here, circle divides the plane into three parts: exterior of the circle, interior of the circle, and on the circle. Circle divides the plane into three parts: exterior of the circle, interior of the circle, and circumference of the circle. It means circumference means on the circle. Okay. Here the power of the point P with respect to s equal to 0 is S11. The power of the point P x1 comma y1 with respect to a circle s equal to 0 is S11. According to the S11 value, we have to say that the point P lies inside on the circle or exterior of the circle. According to the value of S11, you have to say that the point P is interior of the circle, exterior of the circle, or on the circle. Here, observe here S11 less than 0. The power of the point P is less than 0. It means S11 less than 0. S11 less than 0, then the point P is said to be lies interior of the circle. If S11 less than 0, the point P lies inside the circle. Next, S11 equal to 0. Then we say that the point P lies on the circle. It means the point P lies on the circumference of the circle. Next, S11 greater than 0. S11 greater than 0, we say that the point P lies outside of the circle. Okay, yesterday already we discussed this concept. Okay. Okay, next. A tangent of a circle. Tangent of a circle. Already you know very well about tangent in first year in tangents and normals concept. First, here a line touches the circle. At only one point. If a line touches the circle at only one point, that line is called a tangent of the circle. If a line touches the circle at only one point, that line is called, in this diagram, this line is called tangent of this circle. Here, the point of coincidence, where this line touches this circle, that point is called a point of contact. Point of contact of the tangent. Okay, if a line touches the circle at only one point, that line is called tangent of the circle, and the point of coincidence is called a point of contact of the tangent. Okay, next. Next, length of tangent. length of tangent. Here first, what is length of tangent with respect to the circle? For suppose this is the circle, s equal to 0. Here P is one external point to the circle s equal to 0. If a tangent is drawn from P to this circle and touches this circle at the point A. Here, if a line passing through P touches the circle at A, then this length, here PA length, here PA is called, here PA, distance between P and A is called length of the tangent from the point P to the circle s equal to 0. Okay, once again I will repeat here, length of the tangent. If a line passing through P touches the circle at A, then the length PA is called length of the tangent from the point P to the circle s equal to 0. Here this length is called length of the tangent from the point P to the circle s equal to 0. Okay, next. Here formula for length of the tangent. In question given the point P, some x1 comma y1. The point P is x1 comma y1. Now length of the tangent from the point P x1 comma y1 to the circle s equal to 0 is what? Here the length of the in question given point P x1 comma y1, and in question given circle equation s equal to 0. How to find length of the tangent from the point P to the circle s equal to 0? Here this length is what? Here PA. Right. Observe here. Here C. The C is the center of the circle. Here actually this is tangent of this circle. This is normal of this circle. For circle normal always passes to the center of the circle. This is the normal. These two are perpendicular. Here PA and CA are perpendicular. Here this length is called radius. Here CA is called radius of the circle. This length is called radius of the circle. This line is called normal of the circle. Normal of the circle. Observe here. Here PA is tangent, CA is normal. For the circle normal always passes to the center of the circle. This radius is called this length is called radius of the circle. This equation, this line is called normal of the circle. Over here these two are perpendicular according to Pythagoras property. According to Pythagoras property, PA square plus CA square equal to CP square. Here this is the right angle triangle. These two are perpendicular. Now this is the hypotenuse according to the Pythagoras property. Here PA square plus CA square equal to CP square. Okay, PA square. You have to find PA square. Here PA square equal to CP square minus CA square. Okay, right. Here PA square equal to CP square minus CA square. Right. Next, PA square equal to here CP square as it is minus CA square means R square. R square. Already you know that CP square minus R square is what? Yesterday already we discussed. CP square minus R square is called power of the point P. Power of the point P. Here CP square minus R square is also write as S11. Yesterday already we proved. Here CP square minus R square is also write as S11. Here PA square equal to S11. PA square equal to S11. Therefore, PA equal to root S11. Here, the length PA equal to root S11. Now, PA is what here? Length of the tangent from the point P to the circle S equal to 0. Right here, the length formula. The length of the tangent from the point P x1 comma y1 to the circle S equal to 0 is under root of S11. Okay. So next. Position of a line with respect to circle. Position of a line with respect to circle. Suppose L equal to 0 is a line and S equal to 0 is a suppose L equal to 0 is a line. L equal to 0 is a line and S equal to 0 is a circle. Let D equal to perpendicular distance from a point to here D equal to perpendicular distance from center to the line. Here, observe here. Suppose L equal to 0 is a line and S equal to 0 is a circle. The D, small d means perpendicular distance from center to the line. Here, let center of the line. Observe here. First one. Let R equal to radius of the circle. First one, R is greater than D. R is greater than D. If R greater than D, listen here. This is the line. Line L equal to 0. This is R. If R greater than D, the radius of the circle is greater than D. Here what is D? This is D. This is D in this diagram. D. D means what? D means what? Perpendicular distance from center to the line. Here, if R greater than D, like this diagram. Right. This diagram, observe here. Here R is greater than D. R is greater than D. Observe this length and this length. Here R is greater than D. In this case, we say that the line L equal to 0. The line L equal to 0 intersects the circle in 2 points. It means L equal to 0 is a secant of the circle. L equal to 0 is a secant of the circle. Observe here R greater than D. Okay. In this case, if R greater than D, the line L equal to 0 curves the circle in 2 points. It means L equal to 0 is a secant of the circle. Next, second one. r equal to d. Second one, first one r greater than d, second one r equal to d. These conditions are very important. Okay, right, r equal to d, right, r equal to d. Right. Observe here, if r equal to d, r means what? Radius of the circle. D means what? Here d means perpendicular distance from center to the line. Now this length is d. This diagram, r equal to d. Here r equal to d. In this case, the given line L equal to 0 touches the circle. It means L equal to 0 becomes a tangent of the circle S equal to 0. Here, if r equal to d, then the line L equal to 0 becomes a tangent of the circle. Okay, next. Third one, r is less than d. R is less than d. Observe this diagram. Like this, if r less than d, this is the line L equal to 0. Right, if r less than d, here this length, observe this length and this length. What is d? The perpendicular distance from center to the line L equal to 0. And if r is less than d, then the line L equal to 0 does not meets the circle and not touches the circle. Here neither touches nor intersect the circle. Here if r less than d, the line L equal to 0 neither touches nor intersect the circle. Okay, these conditions are very important. Length of the chord. Length of the chord. Observe here, let L equal to 0 is a chord of the circle that L equal to 0 is a chord of the circle S equal to 0. L equal to 0 is a chord of the circle S equal to 0. Now length of the chord required. The length of the chord intercepted by the circle S equal to 0 on the line L equal to 0. Here this is the chord. Okay, here L equal to 0, this line, this chord, this is the chord of the circle S equal to 0. Here this length is required. Here the length of the chord is required. Observe here this length is small d, this is r. The length of the chord, this length is required here. Okay, right. Here observe here, this length is, suppose here AB is a chord. AB is a chord. It is M. From diagram, AM equal to under root of r square minus d square. Here this length is, here M is the midpoint of the chord AB, then AM equal to here AM equal to under root of r square minus d square. Okay, next AB. Here AB means what? Length of the chord. AB equal to 2m. AB equal to 2m. 2 into AM. Here AM equal to what? Under root of r square minus d square. r square minus d square AB, where AB is the length of the chord. Okay, AB equal to 2 into under root of r square minus d square. Observe here. Here in question, chord equation is given and circle equation is given. This is the circle s equal to 0. Here in question, chord equation is given and circle equation is given. How to find length of the chord? According to the formula 2 into under root of r square minus d square. The length of the chord equal to 2 into under root of r square minus d square, where r is the radius of the circle, d is length of the perpendicular from the center of the given circle to the given chord. Here d is the length of the perpendicular from center to the given chord. Okay, students, one problem. Find the length of the chord intercepted by the circle x square plus y square minus x plus 3y minus 22 equal to 0 on the line y equal to x minus 3. Question: find the length of the chord intercepted by the circle x square plus y square minus x plus 3y minus 22 equal to 0 on the line y equal to x minus 3. Observe here. In question given circle equation and line equation. This is the line equation. Here line equation, here chord equation and secant equation same. This is called secant up to this spot. Only this spot is called chord of the circle. Okay, this line is y equal to x minus 3. Now this is the circle s equal to 0. Okay, question: length of the chord. This length is required. Only this length required. Here center, it is d. This is radius of the circle. Here length of the chord, we know formula 2 into under root of r square minus d square. Here r and d are required. R means radius of the circle. Solution: here center of given circle 1 by 2, here 2g equal to minus 1. Here 2g equal to minus 1, then g equal to minus 1 by 2. Center minus 3 by 2. There here. From circle equation, 2g equal to minus 1 implies g equal to minus 1 by 2. Circle, from circle equation, 2f equal to 3. Therefore f equal to 3 by 2. Find radius under root of g square plus f square minus c. Under root of g square 1 by 4, f square 9 by 4, c. So c is minus 22, it is plus 22. Now simplify this. Under root of, here 4 LCM, 4 into 22, 88 plus 10. This is under root of 98 by 4. This is the radius of the circle. Okay, next D. Here center of the circle is what? Center minus g comma minus f. Minus g comma minus f means 1 by 2 comma minus 3 by 2. Here g equal to minus 1 by 2. Here minus into minus plus 1 by 2. Here minus f minus 3 by 2. Center equal to minus g comma minus f. Therefore center is what? 1 by 2 comma minus 3 by 2. Now find D. D. How to find D? D means what? Perpendicular distance from from center to line x minus y minus 3 equal to 0. Here from diagram, D is what? The length of the perpendicular. The length of the perpendicular from center to the given line, D. Okay, fine. According to the distance formula, here D equal to what formula? Distance formula, ax1 plus by1 plus c by under root of a square plus b square. Here modulus of a. Here a equal to what? 1 into x. X means 1 by 2. Next minus 1 into. Here b equal to minus 1. Next minus 3 by 2 minus 3 by under root of a square plus b square, 1 square plus 1 square, a equal to 1, b equal to minus 1. Therefore next it is in denominator it is 1 by 2 plus 3 by 2. 1 by 2 plus 3 by 2 means 4 by 2, it is 2. 2 minus 3, here 1 by, this is equal to 1 by root 2. Finally total it is 1 by root 2. Here 1 by 2 plus 3 by 2, 4 by 2, 2. 2 minus 3, minus 1. Modulus of minus 1, 1 under root 2. Here D equal to 1 by root 2. Finally, length of the chord. Length of chord equal to formula 2 into under root of r square minus d square. R square minus d square. 2 into under root of r square. Here r value is under root of 98 by 4. Therefore r square is 98 by 4. 98 by 4 minus d. It is 1 by root 2, d square 1 by 2. 1 by 2. Okay, next. 2 into under root of 98 minus 2 by 4. 2 into under root of 96 by 4. Okay, 96 by 4. Next it is 4 2s are 4 4s are. Therefore it is 2 into under root of 24. Write as it is. Here 4 into 6. Write as it is. Finally 4 root 6. 4 root 6. The length of the chord intercepted by the circle x square plus y square minus x plus 3y minus 22 equal to 0 on the line y equal to x minus 3. Here 2g equal to minus 1, therefore g equal to minus 1 by 2. 2f equal to 3, f equal to 3 by 2. Now radius under root of g square plus f square minus c under root of 98 by 4. Center of the circle is what? Minus g comma minus f. This 1 by 2 comma minus 3 by 2. Next d equal to, here the length of the chord formula is what? 2 into under root of r square minus d square. Already we find r equal to under root of 98 by 4. Next we have to find the value of d. Okay, what is d from diagram? What is d? The length of the perpendicular from the center to the given line. Here according to the distance formula, find the value of d. Here d equal to 1 by root 2. After getting r value and d value, substitute in this formula. 2 into under root of r square minus d square. Therefore length of the chord equal to 4 under root of 6. Okay, thank you students.